Well, this here is your workshop 4 quiz review. I'm going to walk through a practice quiz just like the previous workshops, and let's get right to it. First question here. We have Elvis and Bob. They're both painting. Each of them are painting 2 walls each. And as they're painting 2 walls each, it looks like Elvis paints 4 square feet every 5 minutes. Bob paints 6 square feet in 5 minutes. Elvis is doing the walls that are 14 by 10. Bob is doing the walls that are 18 feet 3 inches by 10 feet. Who will be the first to finish? Let's take a look at that breakdown here. We have a 14 by 10, that's 140. There are 2 of those walls, and then here is 18 by 25 times 10. And basically we just got to move the decimal point 1 time. So the area here is 182.5. Okay, now there are 2 walls each, so we can multiply by 2, or we can work with what we have. So 140 times 2, so we have 280 over here. So 280, and that's going to be verse 182.5 times 2, and that's 365. And now the rates were 4 square feet for every 5 minutes. So this one here was 4 square feet for every 5 minutes. And this one here was Bob, which was 6 square feet every 5 minutes. And so let's divide those. So we have 280 divide by 4. So we have 70. Then we have 365 divided by 6. And we end up with 60.83. Okay, and over here, let's take a look again. So Elvis painted 4 square feet in 5 minutes. Bob painted 6 square feet in 5 minutes. And so just a quick recap, we had 14 feet by 10 feet, that's 140. There were 2 walls, so that was 280. So 280 total square feet. We were dealing with 4 square feet, so we divided by 4, we got 70. And now technically we have to times that by 5, so that's times by 5, we'll end up with 350 minutes it will take him to paint those 2 walls. Now over here with this guy, that's 18 feet 3 inches. Oh, and before I forget, 18 feet 3 inches is 18.25. Because remember, 12 inches gives you a foot. 3 over 12 is 1/4, which is 0.25. That's where that came from. And so that's that times the 10, which was 182.5, times 2 for there. And now we had 6 square feet per 5 minutes, so divide by 6. And of course, this one here, we times that by 5, and let's see what we get. So let's just multiply that. So we have the 60.83. We're gonna end up rounding that anyway. Times 5. So it's about 304 minutes. And so obviously this one up over here is going to take longer. This one is going to take shorter. Let's make sure we answer the question. Alright, it says, if that's how fast to paint, who will finish first? Who will finish first? And that's going to be Bob. Bob's going to finish first. Alright, next question. So this here is going to ask about independent versus dependent. Independent versus dependent. So something is going to be dependent on the other. The grade you make on the test depends on the number of questions you get correct. So the grade is going to depend on how many you get correct. So the grade is going to be the dependent. How many you get correct is going to be independent. Grade is dependent upon how many you get correct. So let's take a look. Independent variable is the number of questions you answer correctly, and dependent is the variable is the grade. That sounds good, but let's just make sure. Independent variable is the grade. Nope, that's dependent. So we're at the first one. We're good. There we go. And let's keep just moving along here. So this next problem, I want to make sure we read carefully here. So we have Brian takes his daughter to ER for an ear infection in the middle of the night. There are a lot of people in a waiting room, so he concludes it will be a long wait. What type of reasoning was used, inductive or deductive? Well, inductive reasoning is usually moves from specific instances into a generalized conclusion, while deductive reasoning moves from a generalized principles that are known to be true are known to be true to a true and specific conclusion. So let's think about this here for a second. So in deductive reasoning, you end up starting with some type of theory. You have a hypothesis, observation, and then confirmation. Where inductive reasoning, you end up with an observation, a pattern, a tentative hypothesis, and then theory. So it's kind of like two different ways of thinking, two different ways of coming to a conclusion. So in this instance, I want to make sure that if you come across a question like this and you get it wrong, make sure you have me check it. Because this one here, I would have to lean towards deductive reasoning, because that generally works from a more general observation to more specific, where inductive typically moves from specific observations to broader generalizations. And because we went into this room and we observed something that was very general, oh, it's a crowded room, and we came up with a specific conclusion of, oh, it will be a long wait. So I will have to lean towards deductive reasoning on this one. Okay, so let's go on to the next question. So this one, we have someone here that's saying they have a leak in their roof, and they have a new sealant that they're going to try to put on the roof. One can of sealant covers 100 square feet, and their roof is 23 by 15. All right, so let's get the area, which is going to be the square feet of the roof, 23 by 15. Okay, so 23 by 15, 23 times 15, we end up with 345. So we end up with 345. Now it says 100 square feet per can. So if I divide this by 100, we end up with 3.45. So some of you guys say, well, that's below 0.5, so we round down. Not necessarily. If you have 3 here, that's a whole number, so you definitely have 3. But you will run out. You would need to buy that extra can. So 3.14, or actually 3.54, that's not necessarily going to tell you to round down. We need that 0.45, or we're not going to be able to finish that sealant. So we actually end up needing 4 cans. So 4 cans. Okay. So this next question here looks like we're trying to figure out a formula. So we have months, we have total paid. We wanted to figure out some type of rule that'll help us with this problem. Now, since this is multiple choice, we actually can kind of go backwards too and figure out which one actually works here. But I'm going to go through the steps to show you how to actually figure it out without just plugging in these numbers and trying to get the results. But just so you know, if you plug in 0 in for x, plug in 0 for x here, you're supposed to get 1500. So if I plug in 0 for x here, well, 0 times 1500 is 0. 250. Doesn't work. Same thing with this one. 1500 times 250, or sorry, 1500 times 0, 0 is 0, which leaves us with 250. That's not equal to 1500. So we are actually left with either P equals 1500 plus 250x, or P equals 1500 minus 250x. So either plus or minus. Now if we also notice here, this is increasing. And therefore, it's got to be this one, just by simply process of elimination. But at the same time, I'm going to explain to you how to get there. So we actually have an initial point of 0 plus, or 1500. So we started at 1500. And then if you notice here, 1500, you add 250 every single time. So we added 250 every single time. So it's changing by $250. That's a real bad 250, sorry. Every X months. So that's where it comes from. So we systematically broke down the answers and figured out the correct answer. Or you can look at the chart. Well, it's increasing by 250. Therefore, the first two were eliminated already. And then it was also increasing. And so it couldn't have been the last one. All right, let's keep pressing along here. All right, so this one is asking if it's an expression, an equation, or a formula. So if we notice here, we don't have any equal to signs. So there's no equal to signs. It's not equal to another variable. It's not say, for example, it's not saying p equals 1/2 and then n plus 6. It's not saying anything like that. So as soon as I see that, I know it's not an expression. Excuse me, I know it's not an equation. I know it's not a formula. This is going to be an expression. It has a mixture of symbols, it has some variables, it has some numbers, and it doesn't have anything to do with equality. We're not going to try to find a solution here. We can't. Unless we're given something to plug in for n, we really can only just distribute. We really can't figure out, a total or final answer. So this one here is an expression. There's no equal to sign. Next, what is a conjecture? What is a conjecture? So a conjecture, well, that's an opinion. And so it's an opinion or conclusion formed on the basis of incomplete information. So let's look at this first one. A specific case that contradicts a statement and therefore provides it to be false. Not necessarily. The process of reaching a conclusion based on specific examples. Now, conjecture is based off incomplete information. It's more of an opinion based. An educated guess based on available evidence. There we go. It cannot be determined. Nope, it can be. So a conjecture is an educated guess based on available evidence. So it might be incomplete evidence, but it's what's available. Here we're looking at a relationship again, and we're trying to find out the independent versus dependent variables. So over here it says you have your test score depends on the time you spent studying. So test score depends on time studying. So the more time you spend studying, the better your test score is. So let's take a look. Independent variable is the test score. Now, the test is dependent upon the studying, so that's incorrect. Independent variable is the time spent studying. Yes, because that is going to actually determine the test score. So it's going to be this one. This next one, it looks like we have a break-even type of problem. We're actually trying to find where the cost ends up to be equal for renting a U-Haul versus a Penske here. Now, of course, I don't know if these numbers are completely accurate, but let's go look here. For the U-Haul, we have $19.95 plus 49 cents per mile. We have the formula right there. Then Penske, it's 69 cents per mile, no extra fees. There it is. Now, right away, we know that the U-Haul initially is going to be more because we have an upfront cost. But the cost is going to rise much slower because it's only 49 cents per mile. So this Penske here is going to rise much quicker, but there's no cost, so it's going to start out initially cheaper. So we need those two to be equal. So let's put them equal. $19.95 is the upfront cost plus 49 cents per mile equals the 0.69x. All right, so what we have to do now is we're going to get the variables on the same side. So we're going to subtract that 0.49x. We're going to subtract that from each side. Okay, we subtract that 0.49x from each side. And now next, we are left with that 19.95 equals, all right, let's get this lined up so it looks a little nicer. There we go. And so let's subtract that quickly here. So we have, it's a pretty easy one. You could probably do this one in your head, but let's just subtract it. So we end up with 0.2x. Now at this point, we need to make sure we go through and divide. So we'll draw it out. And so we're dividing everything by 0.2. And we end up with 19.95 divided by 0.2. And so we end up with 99.75 equals x. And so what that means is at that 99.75 mile mark, that's when these two trucks will end up being exactly the same. If you know you're going to drive less, then you go with the Penske. Excuse me. If you drive more, you go with the U-Haul. Because remember, the U-Haul has the upfront cost, but it's cheaper in the long run. So more than 99.75 U-Haul, less Penske. So let's go with the answer here. Is that one? That's the one where it's going to be equal. So that's when the costs are going to be equal. Okay, so for this next question, we're going to look at independent versus dependent again. So we have a vending machine. It says the variables are the code entered or button pressed and the product dispensed. Now let's think about it. When you go to, I don't know, I'm sure many people have gone to a vending machine. I've done it before. And you're going ahead and pushing the buttons. So as you're pushing the buttons, that is going to determine what ends up getting dispensed. So that code entered is going to determine what you get. So the product that you get is dependent upon the code. So let's take a look at the answers. The code entered or the button pressed is dependent. Nope, the code entered or button pushed is independent, because that is going to determine the product to be dispensed, which is dependent. So the product dispensed is dependent on the code. So there's that one. So this next one here, we're going to consider this relationship, and we're going to identify the independent and dependent variables again here. So if we look here, this n is over here on this side, part of that expression side. And as we input stuff in there and we simplify, it ends up to become what the m is. So this n is going to determine what the m result is. So we're going to input on the n, and it's going to determine the m. So that means the m is dependent upon the n. So let's take a look. So the independent is the n, and the dependent is the m, because the m is going to be dependent upon what we put in. So that sounds good. Next problem here, we have Gabby's Gym charges members an initial fee of $350 per month after. So the members can calculate how much they have to pay to use the gym, and here it is. Where M is the number of months they have been members. Will's Workout Center charges $65 per month with no fee. And here is that formula. So where M is the number of months again that they have been members. So what we're going to try to do is find the cost. So find where the costs are equal. Where the costs are equal. So let's go ahead and calculate this. And so we have 50M plus 300 equals 65. We want to know where those two are equal. So we'll go ahead and subtract 50M from each side. Remember, what you do to one side of the equation, you must do to the other. So over here, we're left with 300 equals, and that's going to be 15M. And now we have multiplication, so therefore we are going to divide. And so we end up with 15 over here and 15 over here. Remember, what you do to one side, you must do to the other. And 300 divided by 15. Now, that's a pretty easy one to do in your heads, but if you're not comfortable, that's fine. Ends up to be 20. So we end up with 20 equals M. So right at that 20-month mark, that is when they're going to be equal. So if you have your membership longer than 20 months, this one here is going to climb faster. It's going to be more. So after 20 months, it's going to be more. Before the 20 months, that's going to be more. Okay? Or vice versa. This guy here is more at less than 20 months, but it's less after the 20 months. This here is going to be less prior to the 20 months, but more after the 20 months. But we're looking to see where they are equal, which is at the 20-month mark. And let's keep going here. All right, so this next problem, we have someone that's putting a tile backsplash in their kitchen. And the wall size is 40 inches by 20 inches. Now tiles are 4 inches by 4 inches, and she wants to buy a 10% extra to be safe. So how many tiles should she buy? So we have 4 inches by 4 inches, which ends up to be 16 inches squared, or I should say square inches. Now, another way to write that obviously is to write the units with the square. So we can write it with inches like this, inches squared. 40 by 20. 40 by 20. Well, let's do that real quick. 40 by 20 is 4 times 2 is 8. Then we have 2 zeros, so that's 800 inches squared. And so we have 800 and we have 16. So let's do that real quickly here. 800 divided by 16. We end up with 50. We end up with 50. So we have 50 tiles. Now, I bet you that's one of the possible answers, and it is. But we need to have 10% more to be safe. So we can times that by 1.10. Now, you can set up a percent problem if you want. So say we want 110% over the 100 equals, well, 50 is our whole, but we want x, which is the extra 10% there. Now, you could have just put a 10 up there and got the 10% and then added it back, or you can do it in this step and you'll end up with the same answer. You just won't have to add at the end. So, but let's go here. 50 times 1.1, we end up with 55. So we end up with 55 tiles. So we're going to get an extra 5 tiles just to be safe. So here it is. All right, in this next one, we have a pool is being drained. We have a set of data here. It looks like we're trying to get the formula for the amount of water remaining after X hours. Okay, so we see we're draining, looking at how much is remaining after the water's leaving. So that means we're subtracting. So let's take a look at some of the answers here. All right, so it's being drained. We have a subtraction there, and we have a subtraction here. So the first one and third one are gone. So we know that. All right, so next, let's take a look here. We have a starting value of 12,000. Starting value of 12,000, because that's at 0, starting at 12,000. And then we're decreasing from there. So over here, this is saying we're starting at 500, and then we're subtracting. This one here is saying we're starting at 12,000, and then we're subtracting from there. So this is going to be the answer. So over here, again, look at 1,200, and we're decreasing by 500 every time. So the 500 that we're decreasing by is kind of considered the slope. You're going to hear that word quite a bit. Slope. So we're going down by 500, and we're going down by the X number of hours. That's why this is 500X. So it started at 12,000, and we're subtracting 500 for each hour we go along as we try to drain the pool. So that's why it ends up to be this one. Last but not least, it says consider the following relationship. Identify if it's an expression, equation, or formula. Well, this one's pretty easy again. I'm not seeing any equal to signs, so it eliminates equation and formula. There's no equal to sign, nothing. We just have some variables, some symbols, some numbers, and so we end up with an expression. And so we have an expression. And so that is your practice quiz for this workshop. So please just make sure you let me know how I can be of assistance to you. Do not hesitate to email or text me. I'm here for you. I hope that you have a blessed day.